Good evening, everybody. My name is Koji Miyasaka. I'm General Manager from Kanomax USA. Thank you for joining tonight. This is Kanomax USA Technical Workshop. And first, the agenda, we're going to have some remark from Kanomax Group CEO, Mr. Minoru Kano. And after that, we will have a technical presentation by the Chief Albright, the Fume Hood certified. And after that, myself will introduce some Kanomax product overview.
All right, thanks, Koji. And looks like we have audience who committed to come, too busy to do something else. But anyway, let's get started. And good evening, and warm welcome to Kanomax Technical Workshop at the AIHC 2023. My name is Minoru Kano, and I'm deeply honored to speak to you as the Chairman and the Group CEO of Kanomax Group, a leading measuring instrumentation manufacturer from Japan. Unfortunately, I'm not able to be in Phoenix at this time, but on behalf of our entire team, please allow me to extend my heartfelt gratitude from New York City for your presence here tonight at this esteemed event. The AIHCE conference has always been a significant platform for professionals in the field of industrial hygiene and occupational health and safety. It brings together expert researchers and practitioners from around the globe to share knowledge, exchange ideas, and shape the future of our industry. It is an opportunity for us to collectively address the challenges we face and explore innovative solutions to enhance workplace safety and well-being. So tonight, we are thrilled to introduce such an innovative solution for testing fume hood containment performance along with our own products. The distinguished speaker, Mr. Chip Albright, President of Fume Hood Certified LLC, will talk about his unique yet excellent technologies. By the way, Chip and us working together to tackle the problems our customers face. At Kanomax Group, we are committed to pursuit of excellence in precision measuring instrumentation. For nearly 9 decades since our foundation back in 1934, we have strived to develop cutting-edge technologies that empower organizations to monitor and control environmental factors critical to the health and safety of workers. Our mission has been to provide reliable and accurate solutions that enable businesses to make informed decisions, mitigate risks, and create better work environments. Nowadays, we are not only making our own instrument and system, but also eagerly pursue to work together with our strategic partners to extend what we can offer for our customers. Partnering with Chip's company is one of the excellent examples. So this event is not just about presentation discussion, but it is about the collaboration and networking. We encourage all of you to actively engage with your peers, exchange ideas, and forge partnership that can drive our industry forward. The collective wisdom and experience in this room are unparalleled, and by working together, we can overcome the challenges that lie ahead and build safer and healthier future for workers worldwide. So before I conclude, I would like to express my deepest appreciation to our guests, partners, and our team members for their invaluable effort in making this event possible. Your commitment to advancing our industry is truly commendable. Once again, I extend my warmest welcome to each and every one of you, including those who participate online. I truly wish that this opportunity to trigger further insightful discussions, meaningful connections, and groundbreaking ideas that will shape the future of our industry. Together, let us embark on this remarkable journey of innovation, exploration, and collaborations. Thank you very much for your participation tonight.
Thank you. Thank you, Mr. Kano. Okay, so now we have Chip Albright. Chip is president of Fume Hood Certified. He has more than 40 years experience for fume hood testing, laboratory control, and then control the environment of the building. He's also author of the Hue Product Explained. And today, the chip will introduce some innovative technology for the fume hood testing. So please welcome to the chip.
Good evening. Today we're going to go through the concept of fume hood performance testing. And we're going to give you sort of an overview as well as a focus on what it is that we do. The reality is the only way you know that a laboratory hood is functioning safely is to test it. There's no other way to really know. And we're going to talk about the different testing and how it works. So I think you'll find some of what we're talking about to be, fairly interesting. So I think everybody knows what a fume hood is, but one of the things that isn't always understood is that a fume hood's a hybrid device. And so it's partly an engineering control, and the engineering control component has more to do with exposure, chemical exposure. But then it's also a PPE in that the sash and the enclosure protects the user from hazards like fire, explosion, runaway experiments, etc. So what is your fume hood working really mean? And unfortunately, we'll get into it, but unfortunately there's a misconception over the difference between phase velocity and containment. So since the fume hood is an exposure control device, its primary function is to protect the user and the lab occupants from unhealthy and unsafe exposure to hazardous chemicals that are being used in the hood. So loss of containment is a failure of the primary function of the fume hood. So let's look at two misconceptions. The first is fume hoods are standalone devices, and they're anything but that. So a good analogy is fire sprinkler systems. So if you, in a lab, if you're looking at the fire sprinklers, the most you're likely to see are the sprinkler heads in the ceiling. But for that to work, there's miles of piping and pumps and all sorts of other things. Well, the same is true with the fume hood. You can see here down in the bottom there, number 14 is a fume hood, but look at all that stuff that it takes to make it work. So it's a very complex mechanical system, and its performance is highly dependent on what the rest of the system is doing. Phase velocity is not an indication of containment. So in reality, if you go in and you do a phase velocity reading of a fume hood, all that's telling you is the air is going in, it's going in at a certain speed. So it's not telling you what's really happening, and we're going to look at that in a little bit more detail. So interestingly enough, about 70% of the hoods that fail safety containment have an acceptable phase velocity. So there's no direct relationship. Phase velocity is a component of containment, but it's not an indication. And then we have the sort of the legal and regulatory requirements. You would think, as hazardous as hoods really are, there would be a requirement for a standard to test them, but there isn't. So the closest thing that we come to a requirement would be, some of the OSHA guidelines. But failure to properly select, design, use, and maintain a environment or a exposure control device, what happens when you fail to do that? Well, it increases the potential of unacceptable impacts to people's health. It increases the potential to harm the environment. It increases the potential for premature degradation of the lab equipment, increases the potential for loss of productivity, et cetera, increases energy consumption and operating costs, and it puts you at risk of non-compliance and the risk of liability. So again, like I said, the only real jurisdiction out there is a vague description in the OSHA regulations that say as an employer you have to keep the property or the people safe, but it doesn't really require testing per se. Here's just a real quick overview of what they do, but it's meant to, to make sure that employees in the lab are being safe. And as we hear often, safety is no accident. Forget about the fines. The real cost are the potential lawsuits. And the good news on lawsuits is most get settled out of court. So, but they happen very regularly. And so because they're settled out of court, they can get a non-disclosed statement that basically prevents the people from disclosing what the settlement was. So it can run in millions of dollars. So it's actually better to do it right. So testing helps to ensure compliance with regulations. And if there is an incident, we hope there isn't, but if there is, it's going to come down to a paper trail. Who can show that they did the things that they needed to do so that the users were safe? And we have a software solution as well called Fume Hood Performance Software. And what it does is it creates a tracking of every hood. So we can put all the test data out there. We can organize anything and everything pertaining to that hood in a central place where it's easy to find. So that should you have an event a year from now, 5 years from now, 10 years from now, you can go back to the software and show, well, this is what we did, when we did it. And so it's a real good way to reduce your liability. It's also the saying, safety isn't expensive, it's priceless. Testing has shown that 50% of the hoods not performing at safe levels are failing because of the rest of the ventilation system. So the lab ventilation system is the problem. Another 25% come from poorly designed fume hoods or poorly laid out laboratory space. And then the last 25% comes from worker practices. So the people are part of the system, and we'll look at that. So when you look at the health risk, there are three ways to be exposed. You can breathe it, you can ingest it, or you can get it on your skin. So those are the three methods of exposure that we have. And probably the most significant thing to point out is, unlike biological exposure, chemical exposure can take years to show up. So, if you get exposed to a biological agent, chances are you're going to get sick pretty quick. On the other hand, if you have chemical exposure, it may be 5 years, 10 years, 20 years before it shows up. And when it does, it generally is cancer. So with proper testing and training, the risk of working with fume hoods can be greatly minimized. And as we looked at before, you've got three components of safety or in terms of failure, I guess. So 25% again is the hood or the space, 50 is the mechanical ventilation system, and 25% are user work practices. And so really without a holistic approach to safety that addresses all three of these components, you're not going to have as safe of a hood as you would like. So in the United States, ASHRAE 110 is the most notable testing standard, but ASHRAE 110 is often misunderstood. And the way that I pick up on this most of the time is people say, well, your hood has to pass ASHRAE 110. Well, ASHRAE 110 is not a pass-fail standard. It's only a methodology. So then you have to go somewhere else to find out what safe is. And so most commonly here in the United States, we use the guidance in ANSI 9.5. So that would be the most common standard for determining what amount of leakage and stuff is acceptable. So how many of you have seen a label like this? These are pretty much worthless. Yet we'll see them on hoods all there. So what did they do? Look at the day. They did the test back in 13, and it says, well, this hood has 97 feet per minute, so it's safe. Not. So this is what, and our more elite testers refer to the testers that do this kind of testing as lick'em stick'ems. So they basically take a velocity reading, stick the label on the hood, and they're done. And a lot of employers, unfortunately, or a lot of owners, accept that as an acceptable, oh, well, I had my hood tested, so I'm fine. But if I can tell you, if you ever have an incident and it goes to court and this is all you've had done, you're going to have problems. So let's look at the types of ASHRAE 110 testing. We have the first type, which is as manufactured. And the test protocol is the same for all three of these. But what you're doing in an as manufactured test is you're actually testing the hood under perfect conditions. So an ASHRAE test lab has absolutely perfect room conditions. And so what you're really seeing is how well does that hood perform. So now we sell it. It goes out to the customer. So that now as an as installed AI, and we'll probably have to change that to something else since AI is taking on a new meaning, but basically as installed is when you test an empty hood in a lab before it's been occupied. And the purpose for that is to see how it integrates with the laboratory ventilation system. So if the test results you get on an as installed differ significantly from as manufactured, you have a mechanical problem. So that's the first thing we do. Then later on, after the people occupy the space, we do as used. So that's the first time that we have a loaded hood with equipment in it and all of that sort of stuff. And it also is going to impact, like if people have the hood overloaded or they have a lot of stuff sitting on the work surface, things of this nature, it's going to impact the performance. So what, again, we want to do with an as-used ASHRAE test is compare it to the two before it. So if we take as-used and we see the numbers are substantially different than as installed, then we know something has changed in the room conditions or the working practice. So again, between the three of them, it gives you a pretty good indication of what's happening. So typically, it's suggested, a lot of people follow the same criteria they do with biological safety cabinets, and that's annual testing. So that's a real good place to start. So one of the things that a lot of people don't really understand is that there's something in ASHRAE 110 called a face velocity profile. And what they do, as you can see in the graphic, they divide the face of the hood off into roughly 1 square foot squares. And then you go and you do readings in each of those squares. And what you want is you want those values to be pretty flat. And we're going to look at that here in just a second. So what face velocity profile does is it helps us understand how much turbulence. So the more difference there is in the numbers, the more turbulence there is. The more the numbers are similar, the more laminar it is and less turbulence. So let's look at these two hoods. So here's hood A. Hood A, it's got a low of 56 and a high of 114. And you can see some red or pink cells and some white ones. But it's got an average face velocity of 80. Now here we have hood B, and it has the numbers you see there, and it has an average face velocity of 80. Now, what does that really mean? Well, if you look at hood A, it's very turbulent because those numbers are all over the map. And so typically, ASHRAE does say the only place there's a fail to it is if there's more than a 10% variation between the high and the low, they tell you the hood's not going to work, so stop testing until it's fixed. So basically what we have is we've got a situation where that first hood is very turbulent. It's not going to contain. So without even getting out FS6 or anything else, I can pretty much tell you that hood will not pass just by looking at the face velocity. So one of the things that I did for a long time is that the trade association, CIFA, that when members went to join, you had to submit a test to show that your product was ASHRAE 110, met the ASHRAE, using ASHRAE 110 met their standards. And so quite frequently they would give me copies of the test and say, is this real? Because if you have this face velocity, there's no way you're going to have, for example, if you have A's with all that variation, you're going to have FS6 going up and down all over the place. So if I see a test with a horrible face velocity and a flat line on FS6, I know the FS6 testing is not right. So anyway, face velocity profile is a very good way to tell if a hood's working. It doesn't totally replace full testing, but it is a good way. And one of the interesting things is that most everybody that owns a fume hood is in a position to buy a monitor, airflow, a hot wire anemometer. And with that, that's all you need to do your own face velocity profile. So, what we recommend is get the hood tested. They're going to give you a face velocity profile, and then you come back yourself every couple of months or whatever and redo that, because it takes 10, 15 minutes, and then you'll know if the hood is staying where it was or if it's drifted off. So what is the main cause of loss of containment? And it's turbulence. Most people, and having been in the industry for so many years, the one thing that we did that was unfortunate is, like in graphics, we show air patterns and they're nice, smooth arrows. Well, there's nothing remotely similar to that really happening. And we'll see that in a couple of the videos. But basically, turbulence causes the rotation, mainly the vortex, to become unstable. And when that happens, when you have an unstable vortex, then you're going to have loss of containment. So if you're not going to do any other testing, we recommend that you do. But if you're not, at least do a face velocity profile, because here this right here tells a whole lot about how that hood's going to perform. So then the second part of ASHRAE is smoke visualization. So there's a small smoke or local smoke, and then there's a large volume where we put smoke in. And we'll talk about a little bit more about that in a minute, but here in this picture over on the right-hand side there, you can see the smoke's just pouring out of that hood. And so there's a reason for that, and we'll get into it. Now, one of the things is that a lot of what we see when we do smoke visualization is we see the impact that the machine is making. So the next slide will elaborate a little bit on that. So we've developed a machine that's called a Hazer Professional, and what it is a zero velocity smoke generator. So it uses polypropylene glycol, like a theatrical fog type chemical. And what it does is it looks almost like a liquid coming out because we've slowed it down. And so for localized smoke testing, there's not a better instrument out there than what we've done. So we've taken the basic design and modified it to take out the effect that the exit velocity causes. So here's a large volume smoke machine. And you can see from that little video clip there, that smoke's really coming out. And if we put a hot wire in it, we're going to find it's anywhere from 1,500 to 3,000 feet per minute. Well, that's 100 times more than what's happening in the hood. So the smoke machine is actually disrupting the airflow. So it's very hard to make any sort of intelligent decision about what's really happening because you're seeing the impact of the smoke machine rather than the airflow. So then we get into that subject a lot of people want to talk about today is FS6, sulfur hexafluoride. And it's a very strong greenhouse gas. As a general rule, I think people would want to eliminate it from fume hood testing if they could. But this in italics underneath is right out of the ASHRAE 110 2016. And it says, flow visualization and phase velocity test can be conducted without the tracer gas test. And what they basically say, if you read the whole thing, is that we shouldn't use FS6 for routine testing, that we should only use it for fume hood development and troubleshooting. So even ASHRAE 110, if you read every word in the standard, says some things that sometimes people are surprised about. So why is there problems with FS6? It's a very strong greenhouse gas. It's very expensive. In some places you can't even buy it. It also is 6 times heavier than air, and so the hood becomes much more concentrated down at the work surface. So you're not really fully testing the hood because it's coming out of the ejector and falling immediately down to the work surface. And then a leak detector is very expensive, $32,000 right now. And so any leaks that the hood has then contaminates your background. And so if there's any leakage while you're doing FS6 testing, it can literally take hours to flush the room out and start over again. So that is another problem. So just to give you an example of bad practices that happen, I've seen testers come in and have a leak, and they get FS6 in the room, so the background goes up, so they're showing failing before they ever expose the probe to the hood. And so what I have seen done is that they will recalibrate using contaminated background. So if the background is 10 parts per million and they calibrate that to 0, the hood's got to read a huge loss to show up. So, you have to have a certain trust in your testers that they're doing it correctly. So another thing that is said here is that ASHRAE 110, and this is right out of the standard, it does not define safe procedures. So it doesn't really tell us that hood's safe. And what do they say down in the second paragraph? This performance test may be modified to evaluate dynamic challenges. So what they're suggesting is that if you really want to know if a hood works, you need to test it under dynamic conditions. And we'll get into that in a moment.
The next reason is the Tri-Color challenges. Allow me to explain. While ASHRAE 110 focuses on more of the technical functions, Tri-Color focuses on real-world conditions that would be present in a lab. The Tri-Color challenges were designed for visualizing airflow and challenging fume hood containment in a more realistic way. In other words, we came up with different ways to pull smoke out of the fume hood by mocking what would happen in a real lab. So how do challenges tell you if your hood is or isn't containing? Well, do you see green when somebody walks by the hood? Do you see green when you move the sash quickly? Do you see any green when the lab door opens and the room pressure changes? Do you see any green when you pull items out of the hood? If you can see green, that's loss of containment. Your hood might have a problem and should be repaired. If you don't see any green, well, you can be certain that your hood is performing safely.
So what is Tri-Color? Having tested hoods for 3 decades, you know, what you find is there's a lot of people that know how to do an ASHRAE 110 correctly, but there's not so many people that can interpret the results. So it's the documents, you know, are something that are very subjective and saying, well, is this hood safe or not? Now, the only certain things would be like, you know, if they say, well, it's got to be less than 0.1 parts per million, and it's higher than that, then that's a failure. But it's not really actionable information. And so really it's to really know if a hood's working, we need to measure dynamic containment in real world challenges. And that's what we do.
The full open sash position is for setup only, but we want to see what the hood is doing in its worst sash position. So raise the sash to full open and just stand back and observe and see what's going on. Notice the red smoke behind the sash at the top of the hood. See what it's doing and see if you can find any green flares of loss of containment. Here's an example of a poorly performing hood with its sash fully open. You can tell that smoke and fumes are definitely lazily making their way outside of the chamber into the breathing zone. That's an indication that the hood is performing poorly. The design opening is the working height that the system was designed for. It's often around 18 inches, and many hoods have sash stops at the design position. So lower the sash to the design opening, take a few steps back, and just observe and watch to see if you can find any loss of containment light up in green. Here's an example of something like a cross draft affecting a hood at its design opening. Cross drafts could come from many different things. You definitely don't want to see this much green smoke coming out. A person standing in front of the hood creates turbulence that can draw chemicals out of the hood. So all you want to do for this challenge is walk right up to the hood and just stand there. The fume hood is pulling in air from behind you. So when the air goes around you, it can create a low pressure zone right in front of you. That can cause reverse flow and pull chemicals out of the hood. So you want to be watching directly in front of you to see if any green loss of containment comes from you standing in front of the hood. On a failing hood, you can see that somewhat sheet of lazy smoke definitely coming out and into the breathing zone. Opening and closing the sash can cause loss of containment, especially at the edges of the sash. So we do a rapid sash movement challenge to see if movement from the sash will pull air out of the hood and light it up in green for us to see it. Observe what the red smoke behind the sash is doing and watch for any green loss of containment. On a failing hood, notice how we can see the loss of containment when the sash moves up and then stops. It's kind of lazy, it's kind of small, but it is still chemicals that are exiting the hood into the breathing zone, and we want to prevent that. Again, you might get a little better or a little different view if you stand to the side. This can be a tough challenge to perform because you just need to make sure that you have all of your Tri-Color laser cords pulled to the side and not tangled up with each other when you're raising and lowering the sash. Removing items from the hood can cause chemicals to follow that item out of the hood. For this challenge, you just want to grab any piece of equipment, set it inside the hood, and pull it out. See if you can get any green smoke to follow it. Moving large items will make a hood fail more so than moving small items like a beaker or a stand. But you definitely want to try a few different items and observe for any loss of containment. The walk-by challenge, you can almost always get at least some loss of containment, even from a hood that's performing really well, by doing a walk-by challenge. To perform the test, you want to have somebody walk right in front of the hood at a brisk pace, maybe at a slow pace, go to the left, go to the right, just walking by and causing turbulence in different ways to challenge that hood to see if it can keep the fumes in its chamber. Sometimes you can get a better view of the smoke and how it behaves if you stand slightly to the side of the hood as opposed to right in front of it. Here's an example of failure from a poorly performing hood, and you can really tell that it sucked some of those fumes right past the green light and lit it up. Definite loss of containment there with the walk-by challenge. Containment is greatly impacted by the air balance of the room. Opening and closing the door causes the room balance to change. For the lab door challenge, just go open and close the lab door. See if the red smoke behind the sash changes in any way.
The other one that we don't have a good example of is when you have multiple hoods in a room, we like to leave the hood we're testing full open and then go to the other hoods and open and close them. And particularly in the VAV system, that's going to change that. You're going to have lag time issues. You have a lot of different issues. So again, these are real world challenges. These are things that people do every day. And so it's not a static ejector sitting in a certain place or whatever. It's much more realistic. And you know, in lean, I spent a lot of years working with lean manufacturing. And in lean, we say if you can't see a problem, you can't fix it. And so we took that adage here and we said, you know, you don't need a lot of background to see a hood's leaking. I mean, it turns green. You need a little explanation maybe, but you don't have to be educated in airflow to see that. So really seeing is believing. Then another component of our system, as I said, is our software. And so every hood has a QR code on it that we've tested. Some manufacturers are now starting to put our labels on the hoods when they ship them so that we get ahead of the process. But anyway, you shoot that QR code and then it shows you what you're seeing over here on the right-hand side of the screen. It's basically showing you the equivalent of that little label that was on there, but we've done lots more tests. Now, this is a public QR code. So with this particular code, anybody can walk up and shoot it and see this safety certificate. But you notice down in the corner it says view full report. So if you have credentials and you are logged in, it will let you see all this. And this is kind of condensed and too small to really read, but here's a lot of information about the hood. There's a picture of it. There's a picture of the QR code. And then down at the bottom are all the various tests we did. So all of our Tri-Color stuff is going to have videos uploaded. So we can upload everything from reference manuals to architectural drawings about the mechanicals in the room, whatever. So it's a really good place, easy to use to store all of your data. So, you know, evaluate risk. Most of the people using hoods don't really understand what could go wrong. And so if you don't understand the hazards, you're much more likely to be a victim. So hood operators should also be aware of several other things. Fire alarm, safety shower, eye wash, first aid kit, safety manual, fire blanket. These are all common things that everybody that works with the hood should be familiar with and how to use. And I've seen too many people not understand eye washes. You have to stand there and hold your eye open for 15 minutes to properly flush it. If you have a bad spill and you have to use emergency shower, you need to take your clothes off, because otherwise all you're doing is just wetting that acid or whatever it is and holding it to your skin. So, you know, it's not complicated, but it's something if people have never used a fire extinguisher, they wouldn't know what to do. So training is a component. So here's someone doing an experiment. They've probably done it many, many times. And it's sodium being added into water. And it's in slow-mo. That's why we haven't seen it flare up yet. So now it flares up. And as soon as the heat gets to a certain point, it becomes explosive. Now, do you think they planned on that sash breaking? And the answer is probably not. And there's no telling how many times they've done this without that happening. So the problem is with fume hoods, everything's okay until it isn't. So you don't really know what's going wrong until it goes wrong sometimes. So, you really want to train the user about safety. And the sash is really a barrier between the user and what's going on in the hood. So if there's a fire and explosion, you really want that sash in front of you to shield you from what's happening in the hood. So if you want good protection, and I used to do live conferences, and I actually have a photograph of me just like that with a lab coat on and a gas mask. And that's the only way that you can guarantee that the air you're breathing in a lab is safe unless you've done really good testing. So there are two things that you can't see that are important to you. One is, like I said, you don't see the ventilation system. You don't see all that mechanical stuff, the fans on the roof, the air handlers, the VAV valves, all that. But that's very important to the hood performing safely. The other thing you can't see is loss of containment. But probably the biggest thing, if you go away from this meeting with anything, is to understand that face velocity is not an indication of containment. It doesn't tell you if that hood is working or not. And I think, this is probably where the industry, which I was part of for many, many years, has done a disservice to users, in that we have led people to believe that face velocity has some significance, and it doesn't have very much. So the next thing to come up that we want to talk about is, a little bit of prevention is a whole lot better than a lot of cure. So it's much easier to keep something from happening than to recover from it. So lab accidents and incidents are occurring all the time at a very frequent rate. And, if we're going to manage this, we're going to have to rethink about what does it take to make a fume hood safe. Now, we have an agency, a government agency called the Chemical Safety and Hazard Investigation Board, CSB, and they're like the National Transportation Safety Board on transportation issues. This group is chemicals. And so they track all major lab incidents, and major would mean somebody was seriously hurt, or there was a significant loss of property, or somebody was killed. Those are typically what gets you on the list. So between 2001 and 2018, there were 262 significant lab accidents that resulted in 490 people being injured and 10 people dying. So you can pretty much believe that there were probably at least 490 lawsuits. That would be a logical assumption. But when they did this particular study, one of the things that's most interesting is out of the 262, look how many happened at universities, 145. And this isn't no-name universities. We're talking about UCLA, we're talking about Harvard, we're talking about MIT. I mean, it's across the board. And so, it begs the question, and then if you look at high schools and middle schools, they're less, they're 66. And so that's a huge percentage of 262. And so when you let's look at universities, when you look at that and you say, okay, why do universities have such a high accident rate? And what I've been told is, well, we can't train the students on safety because it cuts into our teaching time. And so you have all these students and there's very little training, whereas a commercial company understands liability and they're going to onboard the people, they're going to do a lot more training. And so the better trained the users are, the less likely there's going to be an accident. So there's something in excess of 1 million hoods installed in the United States. And different people have made guesses. EPA did a little bit at one time, but it's estimated that 30% to 70% of that million hoods would not pass an ASHRAE 110 as used containment test with a maximum escape of 0.10 parts per million. So there's a lot of hoods out there that unfortunately don't work. So again, the only way we're going to know if your hood works or not is to test it. There's no other way to know. And like I said, laboratory ventilation is very holistic. It's the fume hood, it's the supply air, it's the room balance, and it's the exhaust. And you have to put all those things together in order to have a well-balanced and functional system. So, lab safety continues to be lax and lacking in most labs. And most experts agree that the underlying problem is how we approach safety. And most places do testing as a regulatory compliance issue rather than as a safety issue. So we really need to think about what we're testing and how. Safety isn't expensive, it's priceless. We said that a little earlier. And everything is okay till it isn't. Accidents are going to happen. They happen every day. Now, some are quite simple and, somebody gets cut or burned or something, and that doesn't rise to the level of a Chemical Safety Board incident. But there's literally accidents happening all the time. So one of the things that happens much more frequently today is that even as fires, lab fires are very, very common, and probably 75% of them happen in hoods. So you have this whole hood thing. So this happens to be St. Andrews University in the UK, and it was one lab in a whole building, but because it was a pretty robust fire, by the time they got it out, they had flooded the entire building. It had smoke damage in the entire building. In the room where it happened, look at all those documents and stuff up there that got burned. So somebody's research probably went up in smoke, as you would say. But, what really you have to understand are labs are dangerous. And if people don't do things correctly, they're going to get hurt. And here's, more examples. I mean, look at the picture of the glasses with the embedded glass in it. So if that person hadn't had those safety glasses on, that they would have probably lost an eye. And you can see over here in the corner, there's a broken sash glass, where if somebody had an explosion, and fortunately it was contained mostly in the hood, and all it did was actually break the glass. It didn't come out like we saw in the video. But then there's another issue with contaminated air. And we'll get into what's happening here in a minute, but he's going to do a real quick experiment. So this is petrol, which is an unleaded gasoline, for lack of a better word. He's going to put one drop in it, and then he's going to take he's going to shake it up and get it dispersed in the bottle. And now he's going to take an electric lighter and light it and stick it down into the bottle. Nothing happens. Now, this is what we would call, it's too lean to be dangerous. So we're on the low side of the LEL, and so therefore it's perfectly safe and not going to create a problem. So now we're going to take the second bottle, and we're going to put 5 drops in. And then we'll repeat the same process. Now that's 5 drops. So it takes, with LEL, with petrol, it has the LEL is at 1.5%, and it's 1.5 to 7%. So now he's going to put 20 drops in, roughly, and he's going to repeat the process. So when we've showed this video to crowds like you, a lot of people, I'd say, well, do you think this one's going to make a really big, and they're thinking, well, if 5 blew up like it did, 20 is going to be huge. It's going to probably break the bottle and everything. So we'll see. So now we're above the UEL, the upper explosion limit. So now in terms, we would say it's too rich. And so it's flammable, but it's not explosive. So we have an explosive range, and this is true for pretty much everything. So here you can see methane. The LEL is 5% by volume. The UEL, which is where we get out of the explosion hazard, is 17%. Now, interestingly enough, look at IPA, isopropyl alcohol. Now, isopropyl alcohol, which is a very common substance in many labs, it's got an LEL of 2% and a UEL of 12.7. So it doesn't take much IPA, and we're not talking about beer, but it doesn't take much isopropyl alcohol to really have a fairly serious explosion. And I've collected for years pictures like this of fires and explosions, and I've been to some of these places in person, and if you go there, you realize, wow, this was devastating. This was a major thing. And I won't go through the whole list, but here's a list of how even small incidents can cause a lot of money. And, you have medical and all of that. But like at St. Andrews, again, it was a small fire isolated to one lab, and it ended, and the good news was when the fire brigade in the UK got there within 7 minutes of the alarm. So they got there very quickly and started trying to extinguish it. The first thing they did after that was cut the power off. So they were within 12 minutes of losing all their biological samples because the sub-zero freezers were warming up. So, they fortunately got the power back on and didn't lose much of that. But there was 120 people working in that lab, and all of them were displaced. So they had to find another place to put that 120 people for 14 months. So that one little fire, I think the estimate was $6.5 million to fix the damage. So you can see even a small fire can be quite expensive. And then the other thing is fume hood performance involves the user. They're 25% of the problem. And while we may not have money to replace our hoods, we may not have money to redo the ventilation system, most of us can figure out how to train the users. So training is a significant issue. And the reality is nobody wants to be a lab accident statistic. You don't want to make the news. You don't want to, get that kind of negative attention. So safety is really important. So I can tell you from personal experience, this is very true. Most organizations don't respond until they have something bad happen. And then they realize, oh, wow, didn't realize that could happen. And now they're willing to do some things to try to correct it in the future. But that one incident may be very, very expensive. So it's very important to test fume hoods. And regardless of what method you choose or whatever, if you don't test, you don't know. And so again, it's something that we need to do. So back in 2020, when we were all sitting around the house wondering what was going to happen, I wrote a book called Laboratory Fume Hoods Explained, and it was extremely well received. It's not a super technical book, as I wrote it in more of a conversational story type way, so it doesn't have a lot of big words, and it goes through the whole system. So it talks about every component of lab, fume hood lab usage. And so the book, like I said, has been very popular. And in talking to people, they say, oh, that was so beneficial. I'm really glad I read the book. So we made a decision about 6 months ago. We made an online course out of it. And so you can actually, and there's in the packets on your seat, there's a barcode like this. And you can actually scan that and take that course for free. So it's everything in the book, plus the videos and stuff that we added to it. So it's a real good resource, and I would, recommend if you look at it and like it, that you share that same information with your colleagues and associates so that other people can do the same. So here again is another shot of it.
Hey there, thanks for reaching out to Fume Hood Certified about becoming a certified fume hood tester. No matter if you're brand new to the testing industry or you're just looking to elevate your ASHRAE knowledge and earn your official fume hood tester certificate, you're in the right place, and we're happy you're here. Our team has over 150 years of combined fume hood experience, and we have created an affordable, very educational, and enjoyable online course that you can complete at your own pace. It's comprised of many different lessons that cover every aspect of fume hood testing. Things like face velocity, SF6 equipment and procedures, hood labeling, minimum report requirements, the history of ASHRAE, and more. That's just to name a few. We're even going to teach you things that you didn't know you needed to know. At the end of the course, you get a live coaching call with one of our experts to go over what you learned, ask any questions, and then we'll mail you your certificate. To begin your certification course, just click the link below and it'll take you to our online course website. From there, you can submit payment, enroll in the class, and start learning immediately. Many of our students have even completed the course in just one day. So thanks for reaching out. You are well on your way to becoming Fume Hood Certified.
So that is another thing that we do, is that we train and certify testers. And so that's a significant part of our business as well. And we've done something working with Kanomax, in that we've printed a document called a fume hood. It's a fume hood tester's catalog. And so if you do any kind of fume hood testing, absolutely everything you would ever want to buy is in the catalog. So it's kind of like the old Sears and Roebuck Christmas wish book. It's got all that cool stuff, and you just hope somebody's got the money to pay for it. But that's something, and again, there's a copy of that on the USB drive there on your seat. And to conclude this, I want to introduce you to something that you may not be aware of. ASHRAE did a new standard. It's called Laboratory Ventilation Design Levels, and it's modeled after biological safety levels. So like we have BSL 1, 2, 3, and 4, we actually have Laboratory Ventilation Design Level 0, 1, 2, 3, and 4. So 5 categories. And here are the categories, won't get into it. But basically, it says, if you're a 0, you don't even need a fume hood. 1, you might need one, but you don't have to be a really good one. But if you've got a 4, you really need to pay attention because that's where something really bad could happen. And they use the H codes for chemicals to help you decide which one of those groups that you're in. So anyway, thank you for your time and attention. Hopefully this has been informative, and if you have any questions, reach out to us. We'll be happy to work with you. Thank you.
There is a question from the online participant. So, let me see. The main advantage of tracer gas testing is the leakage from the hood can be quantified at sub-ppm level. Qualitative visualized smoke tests are not as sensitive. The Tri-Color lighting system seems to improve sensitivity, but have you been able to quantify the smoke when it escapes the hood and is highlighted by the green light?
Excellent question. I mean, basically, we get asked a lot, okay, how much green, is too much, or how much leakage are we seeing? And the one thing I will tell you is, to see it in person, it's a very colorful process. I mean, it looks like a giant lava lamp with all the colors swirling around and everything. So quite frequently when I'm in the lab working on something else, I'll turn it on, turn the hood on and turn Tri-Color on just to have the visual entertainment. But I noticed one time that I was seeing little green puffs of smoke come down in front of the sash. And I thought, well, that's an anomaly. I wonder what that is. Well, didn't pay much attention. They kept doing it and doing it. So I'm like, okay, I need to know what that is. So I started researching it. And what I was realizing was that it was sucking out of the vortex, and it was going over the top of the sash and being pulled down the face of the sash, right through the user's breathing zone, and then back into the hood. So I thought, well, that's interesting. So I wonder how much that leakage is. So I go and get my FS6 equipment out, I set it in the hood, and what do I see? Flat line, 0, 0, 0. And I'm going, it can't be. I see the escaping smoke coming out, so it can't be. So the more I got to looking at it, what I realized was that FS6 doesn't really stress a hood the same way because it's 6 times heavier in air, so it's mostly in the bottom of the hood. And so very little of it gets up into the vortex. So you don't ever challenge that part of the hood up at the top. And so, we're not claiming that you can say this amount of green or that amount of green is too much. We're saying if you see a little green and you're not a 4, class 4, it's probably not a problem. But if you see a lot of green, if it's continuous, if it keeps flashing, if it keeps happening, then you've got a problem. And that's when you break out your FS6 and see how bad the problem is. That's where we call the troubleshooting concept. So, that's a good use for FS6. But, the Tri-Color will show you things that FS6 won't. And so it's something that you don't need a lot of background and training to know what's happening on that hood with Tri-Color. You do need a lot to know what's happening with the results from an ASHRAE 110. So yes, it's not a quantifiable amount, but it serves a very useful purpose, and then it really shows you the consequences of the product over time and what's leaking out and how often and how much. And then you have to make a determination, just like ASHRAE says, with is that safe or not. And so that's a long answer to the question, but I think that what you're seeing with Tri-Color is it'll show you things that FS6 won't. But if you see a lot of leakage, it probably warrants you doing FS6 testing to understand how much is leaking and why. But it's seeing it in person is a whole lot different than what you see here with the videos.
All right, thank you, Chip. Again, thank you again. It's about the human testing and laboratory safety. Those like LEL and then the actual lab incident picture very give me the chill. Excuse me. So then, I'm gonna finish up with this session with the brief, the Kanomax USA product overview. Again, my name is Koji Miyasaka. I'm from Kanomax USA. The first, this is the Kanomax group, the geographic information. So we are in the USA with Kanomax Holdings, and then we have a sister company in Minnesota, Kanomax FMT. In Japan, this is our origin. We have 3 entities, Kanomax Corporation, Japan, and Kanomax Analytical. And in China, we have the holdings, and then also the factory, Kanomax Instrument Shenyang. That's the major factory. We get the product from there. And this is our Kanomax USA office. We established in 1996 in New York City and then moved to New Jersey in 2005. Acquired one of our distributor, and it becomes our current location. From this office, we have sales, marketing, and then also we service our instrument. After sales, we recommended annual calibration to our product, so we have a calibration lab. And we support from here the most of our product. From US, we cover North America, South America, and Europe, and some Mid-East, the region. So this is our office for service, sales, and then also the warehousing. So this is the distribution center of the Kanomax USA office. So this is some core technologies Kanomax start with and then currently have. So fluid measurement and then also the particle measurement. And those instruments are some example of a current product and the solution based on those core technologies. And especially Kanomax is known for airflow technology. So again, based on the fluid dynamic research, and then from that technology, we developed actual testing instrument and then also the engineering solution. And then one of the remarkable technology is the wind tunnel. So to design a highly accurate air velocity meter, we need to also have a technology to create the airflow, the steady airflow. So one of the core competency of the Kanomax is design and develop the wind tunnel to test our product. So again, based on those technology, both fluid and particle research technology, we apply to develop the portable testing instrument for the field usage. And then also, we have a monitoring system for the fixed, like a 24/7 real-time monitoring solution. I'm gonna show some examples. So the first segment, we call the HVAC-R testing segment. And there's a ventilation testing application, and then also the segment laboratory control, where we work together with the chip and then the Fume Hood certified. So product like an airflow capture hood and the duct air leakage tester, as well as the anemometers, those are the professional the instrument tested the HVAC testing and also the performing the system. Especially the high accuracy, high sensitivity and anemometer is the vital. The chip mentioned the phase velocity testing. This is one of the high accuracy anemometer in the market. So a lot of the testing professional utilize this instrument for the phase velocity testing. We also have a indoor air quality testing segment, and the product like gas monitor, IAQ monitor, and we also have a handheld odometer. And the particle counter can be useful for this industry too. And now we are in the AICE, which is focused on the industrial hygiene and then occupational health and safety. In this market, instrument-wise, Kanomax offer dust monitors, and then also the portable aerosol mobility spectrometer. This instrument can measure down to the 15 nanometer up to about 1 micron, and they give you the size distribution of those airborne particle and the aerosol. We also have a handheld condensation particle counter for this application too. Next is the clean room contamination control segment. I introduced a particle counter for the indoor air quality. But many of the clean room contamination testing professionals utilize handheld or a portable type of the particle counter to test that and then also classify the clean room level. And then we also offer the monitoring system, so the clean room user can monitor and then check in the data of their cleanness of the facility, and then also track the incident. Some contamination event happened. They can check the data or like review the data, and then they can fix the problem afterward. And then finally, we also offer the airflow testing solution for the industrial flow testing. A lot of industrial and then also the manufacturing users utilize our hot wire anemometer. The product example is the airflow transducer and also the multi-channel anemometer. We have so many applications. Many of the applications so unique, but our versatile, the product can be fulfill our end users' unique the needs, such as automobile industry or like a data center. There is a critical application to design the facility for the data center, so we can help, and then also the user utilize the Kanomax product. So this is the end of my presentation, very briefly, but Kanomax covered a lot of solution, and then also we offered a lot of testing instruments, as well as the work with the Fume Hood certified or the laboratory control. Thank you for your participation tonight, and this is the end of the session. Thank you. Okay, and again, thank you for your participation, and we have a food and drink, so please enjoy yourself, and then also interact with both the Fume Hood certified members, and then also the Kanomax USA, and the Kanomax holding members, so thank you.
Thank you.